Hey, welcome to 10-8 using matrices to solve systems. The big idea here is by finding the inverse of a matrix, you can solve a system of linear equations. The idea of an inverse, we've used it when we solved for x. Here's a quick example in the text, which is 2/7 times x equals 28. To find out what x is, we multiply by the inverse, the multiplicative inverse of 2/7. That's 7/2, because we want to create a 1 times x, which equals 98. That's kind of the idea when we look at solving a matrix for systems. The identity matrix, and you should have seen this in question 10 and lesson 10-7. The identity matrix comes about from this. If x equals e and y equals f as a system, what was the previous step? Well, the previous step was that 1 times x plus 0 times y equals e, and 0 times x plus 1 times y equals f. Well, the matrix for this is 1, 0, 0, 1, the coefficient matrix, and that's called the identity matrix because a 2x2 identity matrix multiplied times any matrix that can be multiplied by is going to just simply be that other matrix. It's commutative. It doesn't matter which way we go when it's a 2x2. It does matter when it's a 2x1 because we have to have our column-row relationship before we multiply by row-column. The other way around. Row-column relationship before we multiply by row times column. Sorry. So let's try one. Here's our matrix. We want to know the matrix for this, so that's really our first step, is what does the matrix for the system look like? And that's 3, 5, -2, -3 times x, y. And that equals the matrix -23, 14. Well, first up, we would like to find what is the identity matrix for 3, 5, -2, -3. And for that, fortunately, we're going to use technology to make that work. Okay, here we've got our technological solution, our TI Nspire. We're in our home page. What I want to find is an identity matrix for 3, 5, -2, -3. I go first to calculate. That's A. In calculate, I go to menu, and in menu I've got a number of actions, one of which thankfully is 7, matrix and vector, so I'm going to click 7. And then I've got a number of choices, but number 1 is what I want to do is to create one. So I'm going to do a create, and I want to create a matrix, so that's 1. And number of rows and columns is 2x2. I'm going to select OK. And I have my 2x2 matrix. What I'm going to enter is the matrix I'm interested in. And so that's a 3. I'm hitting the arrow button to move to the next box. 5. Going down, that's -3. And then I'm going to go over to -2. Now that's the matrix. What I want is the inverse matrix. And if you'll remember from some of our work, if we raise something to the -1 power, that moves it to the denominator. In other words, takes its inverse. That works for matrices. I'm going to raise this matrix, hitting the caret button, to the -1 power. And this is going to give me the inverse matrix for 3, 5, -2, -3. Going to hit enter. So I got -3, -5, 2, 3 is my inverse matrix for the matrix I was just working with. Let's go ahead and check this out real quick and make sure that it actually works. I'm going to open up a new screen. Well, let me capture this and take it along. Here it is. Okay, so there's my original matrix. I'm going to multiply this times the inverse matrix. And that was -3, -5, 2, 3. What I want to verify is, does this really work? So when I multiply my row by column, a -3 times 3 is a -9. 2 times 5 is 10. Okay? I'm going to go to my next slot. 3 times a -5 is a -15, plus 5 times 3, which is 15. Hey, it's looking suspiciously like it's going to work. -2 times a -3 is 6, plus a -3 times 2 is a -6. Hurrah. And then -2 times a -5 is 10, plus a -3 times 3 is a -9. Do our sums and we get 1, 0, 0, 1, the identity matrix for a 2 by 2 matrix. So -3, -5, 2, 3 works, and using our technological solution allowed us to calculate that. Now we could carry this forward and multiply this matrix, our inverse matrix, times our original matrix, times the solution matrix, but we're going to do that by hand. Okay, so here is our matrix we're working with. I'm going to import our identity matrix, drop it in here, and I'm going to put it here on the other side where I think my equal sign is going to go. Next, I need my coefficient matrix, so I'm going to go ahead and grab that. And here we go. That ought to be enough grabbing for one time. So my identity matrix, my inverse matrix times my coefficient matrix times my xy equals my inverse matrix times my solution matrix. Well, we know, we've confirmed previously that indeed these two equal the identity matrix. And if they equal the identity matrix, then this multiplication times the multiplication of xy is going to leave us with simply xy. And the multiplication for this matrix should leave us with our solution for this whole calculation. So I'm going to go ahead and move to a different page to have a little bit more room. Going to capture this. We'll take it along. So this equals our xy matrix. And if that's true, then we're going to multiply row times column. So -3 times -23 is 69. And -5 times 14 is a -70. So that's our first element in the matrix. 2 times a negative 23 is a negative 46, plus 2 times 14 is 28, and that means that my it's not 2 times 14, it's 3 times 14, and that's going to be 42. So that'll be negative 1, negative 4 equals x, y. So we can say that our xy equals negative 1, negative 4 is our solution to our system of simultaneous equations. I hope this was helpful. You're using technology to create the inverse. If you didn't quite get it, need some help, come in and see me or ask somebody to see if they know how to do it. Best of luck on the mastery quiz, and I'll see you in class.